Hello, I'm Steve Knight, Technical Director at Sertus, and we're here today to talk you through our network control system, CNS-R, as you can see on the wall here. So what we have on the wall here are two different options of control panel. This is a master control panel, and you can determine this by comfort control buttons on the front panel. This is a slave panel. We don't have any comfort controls on this version. These are available in both 5 amp and 8 amp, and if more capacity is needed we have a 24, 30 and 32 amp, but they look a different shape and size, they're a lot bigger. You have various accessories that can go with it, such as the fireman's priority switch up here in the yellow, and the manual control point in the orange colour here, obviously a smoke detector. Then we have what's called a limit switch in this junction box here, which is normally mounted to the side of the motor, which will be up above your stairs or lobby. This system here is just to demonstrate how we terminate the cables and how various functions are switched on or disabled. Some typical faults that might be seen as you're assembling the products. Obviously when we assemble these products on a site, it must be carried out in conjunction with normal building regulations and guidance. So what you will see here are cables with cable ties and not properly made of. This is, I say, just to demonstrate how the system works and how we carry out the connections in the correct place. So these panels are typically used to control a natural smoke vent system, or sometimes mechanical, in a building. They will accept a trigger from either a local smoke detector or from a fire alarm panel, normally via an I/O. They can also be used to control background ventilation, day-to-day ventilation. There are separate controls for that purpose as well. In the event of a fire, obviously the environmental controls are overridden by the inputs from the fire alarm or from the smoke detector. These products will typically be found maybe in a dry riser, or sometimes the master panel will be in a lobby, typically high level, close to the ceiling, fairly distinctive to look out for. Sometimes they're mounted in the dry riser, as I said earlier, but they could all be together as a cluster, and then the wires run separately to each device, or they will be situated on the floor of the device, the smoke vent that it's controlling. We have seen both. There's no rules and regulations about that. You just have to consider the amount of cable you're going to use when you're siting these panels. So these control panels have a plastic enclosure, normally held on with 2 screws at the top and bottom here. Undo the 2 screws, remove it carefully, especially on a master panel, because there will be a ribbon cable connecting the front cover to the circuit board, which we'll explain in greater detail later. So place the cover to one side. We can now see inside the unit, we can see the master PCB with all the various components and terminals. We have recently introduced what we call a Mark II version of the control panel, and the easiest way to compare them is to look at the colour. This is a Mark I, the original, which is green, and the newer versions, Mark II, are black. And I'll explain what the different features are. In the new Mark II version, the fireman's priority switch is now integral on the main PCB. Prior to this, it was via a little socket on the circuit board, a ribbon cable, and a separate, what we called an add-on PCB on the back plate. This worked okay, but it did have weaknesses with picking up EMC, etc. through the ribbon cable, so we've now incorporated it on the main PCB for robustness. We've also introduced extra features on the dip switches here. I'll go through these later, but there is now an auto reset facility in the software, rather than having extra components which you have to wire in. So more benefits on the black PCB. This was introduced in Q3 2020. Another way, a useful way of identifying these PCBs, which we may ask you from time to time when on site, is what software version these PCBs have. And on here you'll see a little white sticker, normally SW for software, 1.005. This is the current software version on the Mark II boards. Likewise, on the old PCBs, we have a software version on here. This one is version 33, which is the latest version for the Mark I PCBs. Other information on the label is the MPS number. We would sometimes ask for this. This is the manufacturing production serial number, so we can trace back when this board was made, who made it, who checked it, in case there's any future troubleshooting required. Let's now have a closer look at the differences between a slave and master panel and how you can identify these differences easily. Let's remove the cover from the master panel. Do this carefully as there is a ribbon cable connecting the two comfort buttons to the main PCB. Remove this from the socket and carefully place to one side. We can now see the master PCB and the slave PCB, and you will notice this has a lot more terminals along the bottom. This has the facility for alarm out relay, a fault out relay, the manual control point here. It also has environmental or comfort controls here, none of which are on the slave panel. They're not necessary. You still have the connections here for the fireman's priority switch, and these connections up the top here are for what we call the bus. This connects two panels together with now a network. So you come out of the master into the first slave, out of the first slave to the second slave, out of the second slave to the third slave, and so on. You can connect up to 35 panels in this network system by this means. Let's just run through some of the components that you will find on the master panel at the top here. So starting from the left and working across, we have the main MCB here, where you have your 230 volt incoming from a non-fused spur. We then have the two batteries at the top with the battery terminals on the top. Very important that these are not shorted out on installation, because there's a lot of amps in these batteries. They're 7 amp hour batteries and it can cause serious damage. So looking at the PCB working across, we have two jumpers. We call these plastic little pegs jumpers. They are links and they join two pins together to form different functions. These two here control the line actuator monitoring. Up the top we have another jumper here. This controls the buzzer, audible on off. This is the buzzer. You may notice the red light come on. This is because I removed the line monitoring, therefore throwing up a fault. Working across, we have the 3 terminals here are for your actuator connections. Normally you would use terminals 2 and 3 for 2-wire monitoring. However, I will explain in greater detail later, sometimes you will need the 3-wire monitoring. Working across the master PCB, these first 3 terminals here are for your alarm out. This is a 0 volt output, extremely useful for connecting to lift to ground or sending information to a BMS system, etc. This is a fault out relay. Once again, very useful for connecting to a remote BMS to tell you that the system is in fault without actually having to go to the panel. These next 6 connections here are for the manual control point, the orange one. We have 3 LEDs, a ground, fire and reset. The next 2 terminals are for your input, either from a smoke detector or from an I/O with a 10K resistor across the cable. The next ones are for your comfort controls. These carry out the same function as the buttons on the front cover, but they allow you to install a remote switch, or indeed a key switch if you want to use it for roof access. Going across, we then have 3 terminals for a weather station. We can connect a rain sensor, a wind sensor, which will then override the comfort controls. And if the system is network, the rain sensor will send a close all through the bus and close every vent that is open. We then have the 4 terminals for the fireman's priority switch, which are now integral on the PCB. Just coming up a little bit, we then have the connections for the bus, as we mentioned earlier. One of the differences with the Mark II is we now have a 4-core bus system rather than a 3-core on the green versions. You need to be wary of this when specifying your cable, that we actually need 4 cores for the new Mark II, but this brings in a lot more robustness. The extra cable is for grounding, to protect it against EMC, noise, floating around the building, etc. Just above the bus connections, we have 12 dip switches, which control various functions. We can go through them in greater detail later. Up here, we have a socket. This is for programming, and we can update the software if necessary. And next, we have a potentiometer at the top here, which is controlling the comfort settings. We'll go into this in greater detail later. And coming across the top, we have a row of 7 LEDs. These 7 LEDs display the status of the panel and whether it's had an open command, a close command, a weather station command, or whether it's in fault. Once again, we can run through these in greater detail shortly. Going to the top now, we have this jumper here, as I mentioned earlier, which is your buzzer, audible, on, off, and this is the buzzer here. The buzzer will sound whether the system's in fire or whether it's in fault, thus warning you that there's a potential error or the system is still in alarm and needs a reset. So now let's look at the components which are on a slave PCB. We've just been through the master PCB, but for the slave it has much the same, although it is missing the alarm out relay. It does not have the fail out relay, it doesn't have the connections for the call point, and it doesn't have connections for environmental. If you need these features, you need to have the master PCB. Apart from that, the controls and the features are exactly the same. Just missing the master and start jumpers here for the bus, because obviously a slave would never be at the beginning and it would never be a master. Once again, I'll explain about this further shortly. And finally, in the middle of the PCB here, we have a reset button. This is standard on all types of PCB, and after the system has been in fire or fail, or you've done some changes, the reset button should be operated here. So let's go through a bit more detail about how we connect the control panel to the smoke vent actuator. As we said earlier, you have the terminals in the bottom left here, and then we're showing the current limiter, or what we know as the lip, mounted to the training rig here. This would normally be mounted on the side of the motor, up above your stairwell or lobby, and this is the actuator that's within the smoke vent mechanism. And we're showing here is that the cables come down into terminals 5 and 6. These are pre-wired in the factory, so terminal 5 will be the blue and terminal 6 will be the brown. This will be sent to site according in that way. Then these connections here are the input from the control panel. Terminals 1 and 2 are the terminals to use. Terminal 1 is connected to terminal 3, and terminal 2 is connected to terminal 2 on the control panel. So if I just connect up terminal 3 and terminal 2 and tighten with a screwdriver, no need to over tighten or you may damage the solder joints on the back of the circuit board. So just nip them up there. Now if your smoke vent is a roof single leaf residential, or indeed a shaft single leaf door, 2-wire monitoring is all that is required, because the 27k resistor is inbuilt into the motor or the lip unit, and this is controlled by dip switch 3 inside the lip, which is the 27k line monitoring resistor. This will come factory set and doesn't need adjusting on site. Therefore, these two jumpers here are also factory set. The top jumper, which is jumper 2, should be in the top 2 pins for 2-wire monitoring, and the bottom jumper, jumper 3, should either be in position 1 or position 2, depending on whether you are controlling one smoke vent or 2 smoke vents, or the system is looking for one 27k resistor or it's looking for 2 27k resistors. Normally it will just be on the lower 2 pins, position 1. Just another point of consideration here is if the distance between the control panel and the smoke vent is significant, you need to be aware of voltage drop. In the back of our manual, page 16, you can see the maximum cable lengths depending on the amps you are controlling, and we are allowing 15% voltage drop. So it's worth checking out your cable runs against voltage drop. We're showing it very close together here. Now let me explain in a bit more detail about how we connect a 3-line monitoring for the actuator. This will be where the actuator or smoke vent doesn't have the 27k resistor built into it. Once again, turning to the 3 terminals on the bottom left hand side of the PCB, we have terminals 1, 2 and 3. We now need to run a 3-core cable up to the smoke vent, and I'm just showing a junction box here. And what we do is we connect a 27k resistor across terminals 1 and 3 to do the monitoring, and then your actuator will come out of terminals 2 and 3 in the junction box. We then need to adjust the jumper, which was in the top 2 pins as factory, into the bottom 2 pins for the 3-line monitoring, and it will now monitor the cable via the resistor in close proximity to the smoke vent. Now let's look at how we're going to connect the manual control point to the control panel. This is done via terminals number 10 through to terminals 15 using 6 cores of a cable. We use a 0.5mm cable, 8 core, and obviously just keep 2 cores redundant. So when you first get the PCB, there will be a 10k resistor across 13 and 14. If you are using a cool point, this needs to be removed. So before we connect the unit up, I will remove this resistor, like so. So I'm going to wire in terminal number 10. This is for the OK LED in the cool point, which is over here. And then turning to number 11, this is for the failure LED in the cool point here. We'll just wire that in with the green. Obviously much easier if you use a multi-core cable with different colours, much easier for fault finding later. So that's the fail LED. The next cable is for the alarm LED, and let me pick the yellow for that. So that's terminal 12. The next terminal, 13, is ground down to here. So let me pick the blue for that. And do that up once again. Do not over tighten, as you could damage the solder joint on the rear. The next terminal is for fire, and I will pick the black for this one. And then finally, terminal 15 is for reset. These are the functions that are available in the cool point. Then turning to the cool point, this was pre-wired earlier. You can see terminals 1, 2, 3, 4, 6 and 7. There is no 5. And very important to make sure that the connections between terminals 14 goes to 7 and terminal 15 goes to 6. Those last two terminals are actually switched in the cool point. And just down to the left here, you can see a jumper, which is the 10K line monitoring for the cool point. So now let's talk through how you connect a Firefighter's priority switch on a Mark II PCB, which is integral. The bottom right hand corner here of the circuit board. 4 cores are required, and I will take each one in turn. The first one is for the open command, so I'll use the yellow for this. The second one is for the close command, so let me take the grey one for this. Once again, very important not to over tighten the cables. We use a 0.5mm cable, fireproof. For this, it's a very nice size and easy to terminate. The next terminal is the LED. We have an open status LED here in the middle of the Firefighter switch. I'm going to use the blue one for this. These terminals are actually numbered 24, 25, 26 and 27. And then lastly, this is a ground. We'll go in terminal 27 and I use the red for this. So that's your 4 cores to the Firefighter's priority switch. Over here we have the terminals 1 to 4, and very important to note that terminal 1, the red, goes to terminal 27, and then terminal 2, the blue, goes to 26, terminal 3, the grey, goes to terminal 25, and the yellow goes into terminals 24. So actually it's reversed when you get to the Firefighter's priority switch. Let me show you what it does if I just switch the power on. Basically you have an open and a close and a reset, and the Firefighter's priority switch has the highest priority out of every device and will override any other control that's been enabled, including the fire alarm. So the Firefighter has complete control over the function of the smoke vent. So if we push open, the system will go into alarm and open the local vent only. If we then do close, it will close the local vent only. Because we've activated the alarm, the system will now need a reset, and on the latest versions of Firefighter's priority switch we have a reset button on the bottom right hand side here. So if I push and hold the reset button, it takes the system out of alarm and the OK light is displayed. On earlier versions of the Firefighter's priority switch, and depending on the software, the reset could be carried out by holding the open and close buttons simultaneously. Let's now look at how a smoke detector or an alarm interface is connected to the control panel. This is via terminals 16 and 17 here, and when the panel is delivered there will be a 10k resistor across terminals 16 and 17. If the system is being connected to a smoke detector, then the 10k resistor will need to be removed and replaced inside the smoke detector, which I'll show you in a minute. If the system is connected to a fire alarm via an I/O, the resistor will need to be removed from terminals 16 and 17 and placed in the I/O to give the correct line monitoring. So we're just going to connect this panel to a smoke detector. So first of all, as mentioned earlier, I will remove the resistor. And then using a 2-core cable, we'll connect this into 16 and 17. So 16 is the ground, which I will connect into here. And this goes to L2 on the smoke detector, which I will show you in a second. And 17 is the smoke terminal, which will go to L1 in on the smoke detector, which I will show you shortly. If you're connecting these cables to a fire alarm I/O, they need to go across the normally open contacts, so that in a fire, the normally open circuit goes closed to trigger the system. So now let's move to the smoke detector. If I remove the head, you can see the grey and the blue cables in. So the grey from ground connects to L2 and the blue from smoke connects to L1 in. And then the 10k resistor, which we removed from terminals 16 and 17, need to be connected across L2 and L1 out. Not L1 in, they need to be connected across L2 and L1 out. And this monitors the cable between the control panel and the smoke detector. And if I just replace the head like so. So now we're going to explain about the bus connections on these panels and how the panels are linked together. So on the master here we have the terminals on the right hand side, and this is the start of the bus from the master, and we come out on the B terminals with a 4-core cable, as we mentioned earlier. This cable will come down to the first slave and come in on the A terminals, and then once again will come out on the B terminals down to the next slave, and so on. The other important point about the slave connections is these jumpers here. On the master there are 4 jumpers, and you set one to say it's the start of the bus. The bottom one here you set to say it's the master on the bus. And then the next slave, there's only 2 jumpers on the slave panels. You set it, the next one, to say I'm a slave. And then on the final slave in the bus, you say it's the slave, and then you put a second jumper in to say it's the end. So the bus is controlled with a start jumper and an end jumper, and then the system knows what's going on. So just a bit more detail on the connections. As we said, the B connections are the out, and B1 will come out and come into A1, and B2 out will come into A2, and so on and so forth. And these instructions are shown in a bit more detail in our installation manual, page 14. We're now going to explain about the environmental or comfort side of the controls. And it's the master panel, as we said earlier, that has this functionality with the terminals here, which connect to a remote switch. As we said earlier, the comfort control buttons are on the front cover, connected via the ribbon cable to the PCB, but a remote switch is often useful, particularly in the case of access to the roof. And here we're showing an external switch wired into these terminals here, down to a key switch here. So if I just remove the cover, so what you can see here is terminals 18, 19 and 20. This is up, down and ground. So our grey is the ground or common. This comes down to the switch and is on the other side of the switch, linking the two together. And then you've got your black here for up and your brown here for down. We'll now put the cover on the key switch and explain the operation. So the operation of the key switch, and as we said earlier, it could be used for access. If we turn the key switch once to the right, we see LED 1 come on, which means the vent is opening, and here we have a motor simulating a vent opening. This is opened for 6 seconds, which is a factory setting on this potentiometer here. If I operate the switch one more time, the vent will open for another 6 seconds and then stop. And I can repeat that for a third time. The vent will open for another 6 seconds, 18 seconds in total, and then stop. The vent will probably be open about 45-50 degrees at this point, and if I try and turn the key switch again, nothing will happen. This is fine for background ventilation or cooling, but if you're trying to get some exit onto the roof, it's still not open far enough, so we need to make an adjustment via this potentiometer, which I'll show you in a minute. Close the vent only requires one action to the close side of the switch and release, and the vent will fully close for the whole of the 18 seconds. So as we said earlier, if this is going to be used for access, you may want the vent to open further, and we would always recommend around 90 degrees for access, so that when the vent is open, it gives you one side of protection when you climb out of the daylight of the smoke vent. So to adjust this, we turn this potentiometer. This potentiometer here has 3 settings. The first setting is the 6-second factory default, and that's how the panels are supplied to site. If we go to the next setting, we can see the line light flash to tell you are in the next zone. This zone is what we would call a dead man's handle, if you like. So whilst you have your finger on the push button on the front of the panel or on the key switch, the vent will open. Release, it stops. Hold to open and release to stop. So you can set the opening angle of the vent any angle you wish, as long as you stand there and hold the switch. To close, you have to do the same thing. You have to hold the key. So there is a little risk of the vent remaining open after use. So we would recommend for access, we actually use the 3rd setting on this potentiometer. So once again, turn a little clockwise until you see the AC line light flash here, which shows you in the next zone. Now this next zone is from approximately 6 o'clock to 9 o'clock, and it's a timer, anywhere between 0 and 180 seconds, which will open the vent fully back to the smoke vent position of 160 degrees. So we recommend go somewhere in between. So if I just roughly gauge somewhere in between and turn the key switch once, you can then release the key and the unit will open for as many seconds as you set on this potentiometer. Can be a little bit of trial and error till you get to the right angle, but very easily adjusted, as I say, with a small screwdriver in the slot. So this is going to open to approximately 90 degrees. So that's timed out. I can reduce the time by turning a little bit anti-clockwise, but this can be finely tuned on site depending upon the size of the smoke vent. And to close, once again, a one operation to turn the key, and it will then close. And then the key can be taken away and kept in the caretaker's office or somewhere for safekeeping. So another part of this system is the ability to have a weather station, which we have up here with a rain sensor and a wind sensor, or you can have just a rain sensor on its own. So I'm now going to wire in the weather station, and these are on terminals 21, 22 and 23. I'll take 21, this is the weather terminal, this is the trigger from the rain sensor or the wind sensor, and then the next terminal is the ground. I'll put my blue into there. And then the final terminal is 24 volt up to the weather station. So I'll just put my 24 volt in there. A point to mention here is that the cable doesn't need to be fireproof, so it's quite acceptable to use flex, 0.5 or 0.75 mil flex on this area, and indeed for the key switch as well. So just to explain the operation of the weather sensor, we have the vent here open a little bit on the key switch, and it starts to rain, so I'll simulate that by touching. the connectors there, and then the vent will close. And you can see here we've got a green LED which is transferred through to every panel in the bus. A rain sensor command will close all to make sure that any vent that is open will close when it needs to.